Yep. Okay. Chapter 3, test hints, regular chemistry. Here we go. Are you ready? Okay. Number 1, test hint says to express numbers in scientific notation. So you are going to get an example of either a really big number or a really small number. And how would you write a number like, well, how would you write a number like this one in scientific notation? 6.02 times 10 to the 23rd. And why is it 6.02 instead of 602?
It has to be between 1 and 10.
It has to be between 1 and 10. Very good. So we have to move the decimal all the way over so that there's only one digit in front. What if you had a number like this?
Maybe the negative exponent.
Do the negative exponent.
You didn't count while I wrote it. I think there's 12 zeros.
So 13 negative 13.
Okay, so how would we write it?
1.23 times 10 to the negative 13.
1.23 times 10 to the negative 13th meters. And we have a unit attached to it. Okay? So the first couple questions will be like that, converting. Yep.
Like, do you only take the 2 after the decimal?
You have to move your decimal all the way over, however far, but so that there's only one number in front of it.
But like, say there was like a 6 and a 5 for 3.
Oh, then you keep going. You write them all.
Okay.
Yeah, so if that was 1, 2, 3, 6, 5, 4, 2, 1, they'd all be there. Yeah. Okay, now in number 3, when you're multiplying numbers in scientific notation, what do you do to their exponents? Add them.
Would it
Okay,
have
so
to be the same number?
not when you're multiplying. That's a good question because that's going to apply to the next one. So when you're multiplying, they can have a different exponent, and you can still go ahead and add or subtract. So say we have 2 times 10 to the 3rd, and we're multiplying that by 3 times 10 to the 5th. Okay, well we know 2 times 3 is 6, and this is going to be times 10 to the something. So we're multiplying, so we're going to add our exponents. 3 plus 5, 8, right? What if we were dividing those? We would subtract the exponent. So 2 divided by 3 would get us what, roughly? Yeah, in decimal?
0.6666.
Okay, 0.66, repeating, times 10 to the what?
Negative 2.
Why negative 2?
Because you subtract.
Subtract the exponent. 3 minus 5. Now, is this correct scientific notation?
No.
No. Let me write my 6 better for the viewing audience. Okay, 0.66 is not a number in correct scientific notation, so how we might have to do another step here. How do we write this correctly?
6.6 times 10 to the negative
6.6 times 10 to the negative what?
30.
Because this is going the opposite direction or the same direction?
It's getting bigger, so you have to make
So what do we do to our exponent?
it bigger. Smaller. Oh, negatives bigger is smaller.
With negatives, bigger is smaller. So what would that be?
Negative 1.
If we have a big number like this one and we're moving the decimal this way, the exponent is positive. Here we're moving the decimal the other way. So the decimal is more negative, right? So what should that be?
Negative 3.
Negative 3, right? Okay. Now, what if we're adding and subtracting these numbers? If we have 2 times 10 to the third plus 3 times 10 to the fifth. That's not going to work so well. Because 2 times 10 to the 2 times 10 to the third is what is a regular number? 2,000. And 3 times 10 to the fifth is what is a regular number?
300,000.
How many zeros? 5. Okay. Now notice that those columns are not matching up. So, to add and subtract numbers in scientific notation, you need to take one of them out of correct scientific notation and make the exponents match. Okay? And let's do this one. How would we make this 3 times 10 to the fifth? 300 times 10 to the third. Everybody see that? Everybody agree?
Agreed.
Okay, then we could add them together. All right. On tests, I will be giving you an OGT calculator to use. So you will have a calculator. It will do exponential notation. You have to use those instead of your own because people punch stuff in and cheat. So you'll be using the calculator I give you, but you will have a calculator. Yes?
I thought the number had to be between 1 and 10.
It does. In proper scientific notation, it does. And then we're going to do our mathematical operation if it's addition, subtraction, and then make sure we're back into correct scientific notation when we're done. Yeah, it's a good question because I didn't finish that problem.
I don't know the school address.
I'm taping. I got to finish this right now. School address is in ER on the webpage. Okay. Number 5. Oh my goodness. Define accuracy and precision. How do we know if we're accurate?
If it's close to what?
If it's close to the what?
Accepted value.
Accepted value. So we have to be able to compare to a commonly agreed upon standard or value, which we find in the CRC or the back of our book, or a vetted source online, not just Wikipedia, or, you know, Wally Wolverine's chemistry site. Some vetted source. So if a measurement is close to its accepted value, that is accurate. What is the difference between that and precision?
Is it precise like multiple?
Precise involves multiple measurements, multiple results, and they are all what to each other? Close to each other.
But not to the accepted value.
They don't,
Not necessarily.
maybe not close to the accepted value, although sometimes it could be. Okay? So hopefully it's close to the accepted value as well.